On this 2011 to 2022 F250 Superduty with the 6.2 gas engine, P0068 means the PCM may be seeing throttle position and airflow or load information that does not agree. The truck may have poor throttle response, idle issues, or limited power, depending on how the failure shows up. Broadly, this can involve an intake or PCV air leak, MAF or MAP signal concerns if equipped, throttle position wiring, electronic throttle body wiring, connector problems, or a throttle plate restriction. Treat it as a correlation diagnosis, not as a parts call. P0068 is sent into the electronic throttle control diagnostic path. The code sets during the KOER self-test when the PCM sees readings that are not consistent with calibrated load values. The PCM is comparing throttle position against MAF sensor readings, so an intake air leak at a hose, line, intake connection, or PCV system connection may be enough to set it. Before getting into the pinpoint checks, have the connector information, circuit identification, and fault trigger logic in front of you so you are testing the right terminals. Start with the basic system checks, then follow a structured diagnostic approach. If other codes are present, check what they mean first and diagnose those first when the path calls for it. One important caution: the first decision point in this path checks for specific companion electronic throttle codes, and it does not give a clean P0068 only continuation. If P0068 is the only code and none of those companion codes are present, pause, recheck the earlier diagnostic path, and avoid guessing. If one of the specific self-test related throttle codes is present, repeat the KOEO or KOER self-test with the ignition on. Do not apply the accelerator pedal during the self-test, because that can create a misleading throttle-related result. Also remember that a failure mode effects management action may set another throttle control code. If additional codes return other than that small group, diagnose the code that came back. If they do not, continue into the throttle body checks. With the ignition off, keep your fingers away from the throttle mechanism. This system can apply substantial opening and closing torque. Make sure the electronic throttle body harness connector is seated correctly. Remove the inlet tube from the throttle body, then inspect the air induction system for restrictions. Inspect the throttle plate for obstructions or deposits, and look closely at the electronic throttle body harness and connectors. You are looking for damaged wiring, damaged connectors, crossed TACM circuits, pushed-out pins, corrosion, or incorrect connections. If you find a concern, repair it as necessary. Clear the PCM DTCs, and repeat the self-test. If that inspection is clean, the P0068 path continues into throttle position reference and signal circuit testing. With the ignition off, disconnect the ETB-TPS connector. Turn the ignition on and measure between ETC ref pin 5 at the ETB-TPS connector and ETC-RTN pin 4 at the ETB-TPS connector. Watch probe polarity. The acceptable VREF check is 4.5 volts to 5.5 volts. If it is not in that range, move into the VREF diagnostic path and do not guess past it. If it is in range, turn the ignition off, disconnect the PCM connector, and check the TP number 2 circuit from pin 3 at the ETB-TPS connector to pin E12 at the PCM connector. That resistance needs to be less than 5 ohms. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. Next, check the TP circuit for a short to ground. The resistance needs to be greater than 10k ohms. Then check for TP circuits shorted together by measuring TP number 2 pin 3 to ETC ref pin 5 and TP number 2 pin 3 to ETC RTN pin 4 at the ETB-TPS connector. Those resistances also need to be greater than 10k ohms. If either short check fails, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Finally, turn the ignition on and check TP number 2 pin 3 for a short to voltage. If any voltage is present, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If no voltage is present, P0068 moves toward the open and closed throttle position check, while certain companion throttle codes move through the TACM motor circuit checks first. When the companion throttle code branch sends you into the TACM checks, keep the ignition off and disconnect the ETB-TACM connector and PCM connector. Check the TACM plus circuit from pin 1 at the ETB-TACM connector to pin E106 at the PCM connector, and the TACM- circuit from pin 2 at the ETB TACM connector to pin E85 at the PCM connector. The open circuit decision is the resistance less than 5 ohms? If not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. Next, check TACM plus and TACM minus for a short to ground by measuring between TACM plus pin 1 and TACM minus pin 2 at the ETB TACM connector. That decision is the resistance greater than 10,000 ohms? If not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Continue the TACM harness check by testing TACM plus and TACM minus against the power ground, VPWR, ETCRTN, and ETCREF circuits at the PCM connector. The idea is to prove those motor control wires are not shorted into ground, power, reference, or return. The decision is the resistance greater than 10,000 ohms? If any part of that check fails, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Then check whether the TACM harness circuits are shorted together by measuring between TACM plus pin 1 and TACM minus pin 2 at the ETB TACM connector. Again, the decision is the resistance greater than 10,000 ohms? If it is not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If the harness checks pass in the TACM branch, measure the component side resistance between TACM plus pin 1 and TACM minus pin 2 at the ETB TACM connector. The shared decision is the resistance between 1 and 90 ohms for KA 1.5L, or between 1 and 900 ohms for all others. For this Super Duty application, the all others range is the useful comparison. If the TACM resistance is in range, continue to the open and closed throttle position check. If it is not in range, that branch supports installing a new electronic throttle body, then clearing the PCM DTCs and repeating the self-test. With the ignition off, reconnect the ETB TPS connector and the PCM connector. Turn the ignition on, access the PCM data, and monitor the TP1% PID. Press the accelerator pedal to the floor and release it. For this Super Duty platform group, TP1 should be 8.0 to 20.0 with the pedal fully released, and 84.7 to 93.7 with the pedal fully applied. Make sure the accelerator pedal is not applied during the fully released measurement. Also keep in mind that some failure mode effects management strategies can prevent the throttle plate from opening. If the throttle plate does not open, treat that as a failed check. If TP1 is within range, the concern cannot be duplicated or identified at that time, so move to the separate intermittent or no fault found path instead of condemning a part. If TP1 is not within range on the P0068 style all others branch, continue to the intermittent concern check. Turn the ignition on and monitor the TPA RCNTF status PID in the PCM. If the PID value changes, repair the concern you find, clear the PCM DTCs, and repeat the self-test. If the value does not change, the concern cannot be duplicated or identified at that time. At that point, move to the intermittent or no fault found diagnostic path and avoid replacing parts without a confirmed fault. If the path calls for the TP signal response check, turn the ignition on, access the PCM, and monitor the TP1 voltage PID and TP2 voltage PID while disconnecting the ETB TPS connector. If the TP1 and TP2 PID voltages change, continue with the connector confirmation. If they do not change, move to the separate intermittent or no fault found path. For the connector confirmation, turn the ignition off, disconnect all PCM connectors and the ETB TPS connector, and inspect for pushed out pins and corrosion. Reconnect everything. Make sure the connectors are seated correctly, and verify whether the concern is still present. If it is still present, that branch supports installing a new electronic throttle body throttle position sensor, then clearing the PCM DTCs and repeating the self-test. If the concern is gone, the system is operating correctly at that time, and the fault may have been from a loose or corroded connector. After any air induction, connector, wiring, open circuit, short circuit, throttle body, or throttle position sensor repair that the test path supports, clear the PCM DTCs and repeat the self-test. Keep repair verification separate from the circuit testing. Verify the repair and confirm the code stays gone. The takeaway on P0068 is simple. Prove the airflow to throttle correlation problem first. Check for leaks and basic throttle body issues, then test the TP reference and signal circuits in order. If the path moves outside the information you have, pause, recheck the earlier diagnostic path, and avoid guessing. For more diagnostic training, visit stepdiagnostics.com.